We're given that A is the vector 3i minus 4j plus 2k, and that B is the vector 2i plus 5j minus 5k. We want to find, firstly, A plus B. This is very easy to do in column vector form. We just do 3 minus 4, 2, and add 2, 5 minus 5, and then simply add the top numbers. 3 plus 2 is 5. The middle numbers, minus 4 plus 5 is 1. And the bottom numbers, 2 add minus 5, is minus 3. So we add the I components, add the j components, and add the k components. Now let's consider 3a minus 2b. If we work in columns again, 3a is 3 times 3 minus 4, 2. And then we have minus 2 times 2, 5 minus 5. Multiply by the scalars first. If we do 3 times the vector 3 minus 4, 2, we just multiply each individual part, giving us 9, minus 12, and 6. We then multiply the second vector by minus 2, so we have a plus in between, and minus 2 times 2 is minus 4, and then we get minus 10 and plus 10. Now we simply need to add. 9 add minus 4 is 5, minus 12 add minus 10 is minus 22, and 6 plus 10 is 16. We now want to find A minus 2B, so we have A minus 2B. A is the vector 3 minus 4, 2. Take away 2 times 2, 5 minus 5. So we just have A, 3 minus 4, 2, and then multiply the B by the minus 2. So we have plus, minus 4, minus 10, and 10. 3 add minus 4 is minus 1. Minus 4 add minus 10 is minus 14, and 2 add 10 is 12. If we now consider the modulus of this last vector, we know from previous work that this is just going to be the square root of 1 squared plus 14 squared plus 12 squared. So this is the root of 1 plus 196 plus 144 which is root 341. Approximately, this is 18.47.